But why? Why are neither of them never 0? Why will tangent never have horizontal? Is that what we're talking about? No, we're talking about undefined. Vertical asymptotes? No.
No, horizontal asymptote.
Horizontal tangent lines? Got it. Show that tangent and cotangent don't have horizontal tangents. Interesting. Oh, because they're more... I don't think I ever put that together before. I should have. I just had a homework problem. Anyway. Yeah, I guess you could have just graphed them and shown that secant never hit 0, but the easier way is if you were to set this equal to 0, then you would have 1 equals 0. That's how I would have done it algebraically. Like actually set equal to 0, multiply by cosine squared. Well, 1 equals 0, which is never true. I mean, you could go like super imprecise and talk about how secant bounces off of cosine. And so it'll never be in the values in between 1 and -1. I don't know. Different ways of doing it. Yeah?
I'm sorry to question about that. So I know like it is not 0, but I was wondering, since the concavity changes,
Somewhat. There is a point of inflection. How can there be a point of inflection and not be a horizontal tangent line? Where are pips? Ips. Ips that come from pips. Zeros and DNEs of the second derivative. Technically, it's not found from the first derivative at all. So sometimes the 0 of the first derivative are also the zeros of the second derivative, but sometimes no. Oh, the first derivative?
no, I meant the original graph. Like, what is it?
Oh, well, tangent itself, it just never actually levels off. It's a little bit, yeah. That's what's going on. Which could be similar if you have points of inflection that are any sort of, it could be DNE, like undefined, or the slopes of the tangents could be actual numbers. So you would never find them if you didn't go to the second derivative. Yeah. All right, any questions on the odds? I think I have the book pulled up just in case over here. If you guys do have any questions. 30 what, Issa? 35? Anything else besides 35? 32? Wait, 32 is not a problem. 13, thank you. Let me just circle them. So we have 13, oh, which 13, sorry.
The bottom. Wait, no, the top one.
Oh, I can't circle anymore. There it is. The bottom one, right, Hannah? Ooh, top one. You said yours is 35 on the top one. So we have 35 on the top one, we have 13 on the top one, and I missed one. 31? 31. On the top one? On the bottom one? Anything else on the bottom one? Did Riley hand off any questions to any? Oh, she's gone today, though, isn't she? Oh, okay. I think period 1 and 2 like marked her absent. I don't know why. Got it, but then she came in time. Got it. All right, so we're doing section 3.4 is where the majority of our questions are, which makes sense, right? Because that's the motion-y rate one. Oh, that didn't help at all. Never mind. Section 3. Hmm. 13 was the first one, right? The first question that we had? Yeah. 13, 31, and 35. So number 13. Okay. Ooh, it says the word aloft. I love this question. All right. What part of it did we get stuck on? We have a position function, meters. Time is measured in seconds. We have the initial velocity. Yeah. Find velocity and acceleration as functions of time. You guys just did first derivative, second derivatives, right? Okay. B, what are they asking for? How long? Find who? What? Quantity. True, but you're trying to find what? Good, you're trying to find time. Okay, that was rough. Find t when? What did you say, Justin? When the derivative equals 0, when s prime equals 0. S prime is the same thing as velocity. Why would velocity be 0 be the maximum? Oh, it's the critical number, right? You're going to have a horizontal tangent. Velocity is going to reach a positive upward velocity before it starts going down. What was letter C? How high did the rock go? Aren't you going to find a time here? So then how high? Isn't that finding S of T sub, T sub H for T highest? There we go. And then what's letter D asking? When? Pause, pause, pause. Find what quantity though? When, time, when. Find T such that height, who's that? S. When S of TH all over 2. Can we do that? Because this will be how high it goes, so then just cut that in half. Man, these are all building on each other, and man, that looks like delta. I am so sorry. When? But aren't you going to have to find the how high to set S equal to find T? We'll get there. Hold on. I'm coming back. I'm just getting all of them worked out. Find how long was the rock aloft. Love it. Find T such that. When does the rock stop being aloft? When what hits 0? Position. Good. Okay. So where are we stuck on? I mean, all of them build on each other, right? So for letter A, wouldn't we have to find, let me change the color just so it's something different. S prime, that would be 24 minus 1.6, 1.6t. Setting that equal to 0, that's going to be our letter A. So our velocity is going to equal 0 at, I didn't even write A because it was so easy. Thank you. I apologize since it was so straightforward. Anyway, setting position, velocity equal to 0, then we can go ahead and subtract the 24, divide by 1.6, which would end up being 240. What did you guys get? 50? Oh, that makes so much more sense. I'm like, 50 doesn't make sense. Okay, so 15 what? Seconds? Meters? Seconds. That's what I called TH. That's the time when it's at the height, at the maximum height. So then letter C says, okay, well, how high did it go? Well, fine, I can just plug in and find S of 15, right? And what did you guys get when you plugged in S of 15? 180 meters. Cool. Then D says maximum when, find T, such that its position is 1/2 of its maximum height. That makes sense, right? But then we have to go ahead and take the position formula, which is 24t minus 0.8t squared. What's the struggle of solving this one by hand? If you had to solve it by hand. It's a quadratic. I guess you could complete the square. It's not impossible. Was it a decimal answer in the back? Party poopers. But what you could have done is you could have gone ahead and divided both sides by 0.8. You would have had n by a negative. You would have had t squared minus 24 divided by 0.8 would be 24 times divided by 4/5, which would be 24 times 5/4, which would be 1 and 6 and 30. To complete the square, you would have had to take half of 30, which would be 15, square it, which would be 225, which side you also do to the other, so 225. You could have had t minus 15 squared is equal to 90 divided by 4/5 would be 90 times 5/4, which would be 1 and 2. Ooh, that's not pretty though. 225 over 2. Which that would be doubled and then cut it. That'd be 225 divided by 2 equals t minus 15 squared. Plus or minus square root both sides and then add the 15 and then you have an equivalent. That would have been fun. E, how long was it aloft? That's easy. Just set him equal to 0. Factor, right? Set each factor equal to 0. 1 is 0. Forget him. I want not where it started at 0, but when it landed at 0. So that would have to be pulling out the t Yeah, 24 divided by 0.8, which would just be 30 again. P.S. I didn't actually finish that with a decimal. You can plug it into your calculator. Wait, how do you plug this into your calculator? You could make y1 this guy and y2 that guy and find the intersection. What else could you do? Because remember, the intersection could be out there somewhere in the nebulous. Go play with your window. How do you get it in by the x-axis? Subtract the 90. That's y1. Find the zeros, because the zeros will hit at the x-axis. Just keep making the x-min, x-max broader, and you'll find it. Does that kind of make sense? E? Yeah, because the rock starts from the surface of the moon, and then it's going to land again on the surface of the moon. That's when it stops being aloft or in the air. And so when you set equal to 0, we're going to factor out a t, and then set the remaining factor, which would be 24 minus 0.8t equal to 0. Is that cool? Okay. You guys also had a question on number 31. This same homework is on the next page, though. It's on the next page, though. Ooh, it was a group activity that you had to do by yourself. I'm so mean. All right. What was going on in the group activity that you did by yourself? They have graphs. One is position, one is velocity, one is acceleration. Wait, one's an original, and one is a, I don't want that. One's an original, one is a first derivative, and one is a second derivative. Do I like you guys knowing how to relate derivative graphs with each other? The answer is yes. How do you relate derivative graphs with each other? Who's who? I don't know. I see a cubic and a quadratic and a linear. Who would have to be the original function? The cubic. C has to be position, because what's the derivative of a cubic? A quadratic. Velocity. So position has to be a cubic so that its derivative, velocity, would be a quadratic so that its derivative, acceleration, would be a linear. Oh, lo siento. Yeah, that's good. You can say a cubic's derivative is a quadratic whose derivative is a linear. Dun, 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 dun. Good question, though. Yeah. So then number 35. Shoop, shoop, shoop. Volcanic lava fountains. Does anybody else feel like these examples are way more exciting than last year? A world record. I actually thought this one was kind of cool. A line of fountains along the wall of the crater. Activity was later confined to a single vent in the crater's floor, which at one point shot lava 1,900 feet straight into the air, a world record. What was the lava's exit velocity? Although we've had quite a few volcanoes lately, so I'm not sure if that's still the world record. What was the lava's exit velocity in feet per second in miles per hour? Now they give you a hint. If the initial velocity is the exit velocity of a particle of lava, its height t seconds later will be, isn't this just like the acceleration-y thing? 1/2 of gravity t squared, negative 1/2 of gravity t squared plus initial velocity t plus initial position, which is 0 because it's exiting the volcano. Begin by finding the time at which ds dt is 0. Neglect air resistance. Well, they told you where to start, right? So where do we start? Who's this guy? Position's derivative. And whose position? This guy. And whose initial velocity? Okay, so, all right, fine. How do we take the derivative of someone whose initial velocity we don't know? We see initial velocity as still a constant. You guys agree? And then we set that, like they told us, equal to 0. So then we can say initial velocity is going to equal 32t, right? What do we know about the information that they gave us? Come on. Come on. What's the number that we haven't used yet? What is 1900? The maximum. When does the maximum occur? at a horizontal tangent. So the maximum is going to occur when the derivative is equal to 0. Wait a minute. Do I care about t? I mean, yeah, I could. What do you guys want to end with? Do you want to end with v sub naught or end with t and then go back and find v sub naught? It's up to you. I don't care. Okay, so if we're doing t and then v sub naught, then we're going to go ahead and keep it the way it is. But this guy doesn't get plugged into t. Sorry, he gets plugged into v sub naught. The position will be 1900 when the derivative is 0. So we can use this to go ahead and go plug in. So we have 1900 is equal to 32t times t minus 16t squared, which leads us to 32t squared minus 16t squared is 16t squared. T squared is equal to 1900 divided by 16, which would be 1 and 30 and 2, no, just 1. I'll divide by 4. So that'd be 4 and 7 and 5. Double check, I did real fast, sorry. 4 into 19 is 16, carry the 3. 4 into 30 is 7, carry the 2, and 4 into 20 is 5. Got it. So now how do you finish it? Plus or minus? Nah, we don't care about the negative time, do we? Positive time. So t is equal to, I don't know, something over 2. Derivative of 475 wouldn't be 20. 21, 22, 23, 24, 25? Nope. Okay. Does 25 go into it? I think so. Because 5 goes in 95 times, and 5 goes in again. I think 19, right? Yeah. Oh, sweet. So it'd be 5 square root of 19. Or plug it in and get your decimals. And what's our seconds, right? You guys, right there, 1900. It's the max. But okay, fine. It was a little tricky. I think we covered all the ones on section 3.4, right? 13, 31, 35? So our last one is section 3.5. I'm going here. Key terms. As I pull it up, I think I also have your Google Classroom here. Have any of you guys not written down your test review yet? I'm going to freeze the screen so you can write it down as I pull up the one for Aryan's question. Instructions. There you go. Boop. Hey, it doesn't look too long, yeah? Not all. Simple harmonic motion, ghost springs. It's number 13. Is anybody still writing it? A couple more seconds. That's a good question. I don't think there is necessarily a perfectly right answer. I would think somewhere in there should be a description of how it's oscillating. It's a periodic function going back and forth. That's a super huge key for simple harmonic motion. You could also talk about how, I think in general, it's kind of asking the idea of a sign chart in the sense of how it's going to be, so you're not going to like describe it forever, but just the general idea of what it's doing each cycle. So I would say describe one cycle. Does that make sense? Like as far as positive velocity, negative velocity, I mean, you could just do speed. I think the speed is probably like the application of it to the actual motion of the body. Going up, going down, speeding up, slowing down. That would be good. Why not just do speed increasing, speed decreasing? Wouldn't that be putting together velocity and acceleration? That's what I would do. Justin.
For those functions, when you apply them to the motion of the body, does that only apply to moving left and right? Because like when it's like positive, you're moving to the right, when it's negative, going to the left.
You could do it right and left, but if you're actually thinking of like a practical application of this, like a spring, it would be up and down.
But if you do it that way, doesn't that mean you can't also do left and right? Like
We'd have to choose
yeah.
whether you want it to be an up-down model or whether you want it to be a right-left model. And it could be right-left if it was something like, what am I thinking of? That goes out and in. Well, this works. There's an old toy. I don't even know what it is. That has like a track and it's a little wheel and it goes along and it goes up and it goes back and it goes up and it goes anyway. That doesn't help you at all. I was thinking like a punching arm where you can like have it go out and back. I don't know. Right-left model would be much less common for simple harmonic motion unless you're talking about waves. I guess you could do waves. I guess that would work. Springs are a little bit. It's just what pops in my mind first. But yeah, you can choose right, left, or up, down. It's your, since they didn't give you a specific example, it's your choice. Okay, are we done with questions on 3, 4, 3, 5? Okay. So test review, we have that ready to go. In the sense of, I just took it away, and I'm sorry about that. Not many of you have your books, although some of you might. Let me go ahead and go grab the review exercises. In our notes for Chapter 3, I technically have, what are these? Are these in your review? I have too many windows open right now. I apologize. It's not your review. Seven, 9, 17, 27. 7, 9, 17. Okay. Kiddos, there's the review up on the screen. You guys know you don't have to write the directions or the problems if you don't want to. I am peeking at the review really quickly because I had some extra problems and I don't remember where they came from. Yeah, Aryan, what's up? I don't mind partner group up as long as you are productive. Does that sound good? Oh, what I have in your notes was the beginning of homework. Never mind, I got it. Okay, let me go ahead and freeze the screen on, I can zoom out just a little bit, I think. This will get you the beginning of homework or the beginning of the review. Actually, it might get you all of it. What problems do we have? 7, 9. What else do you guys need after 27? 7, 9, 17, 27, 35, 45. This gets you through the majority of the review. All right, let me freeze the screen so you guys can start working. If you want to move around to work with other people, you totally can. I might give you a couple hints about the test in just a moment or two.